All right, so today we're going to take a look at 3, 4, which is a little bit more with division of polynomials, except we're going to learn a shortcut for long division when our problems are a certain type. Okay, and it's called synthetic division. All right, when you're finding roots to a polynomial, they can have both rational roots and irrational. Okay, rational roots are roots that you could write as a fraction. Okay, so in the homework, you got a root of 1/2. That's rational. Okay, we just did one a few minutes ago, and we got, bless you, we got square root 3. Well, that's irrational. You can't write the square root of 3 as a fraction. All right, so there's two types of roots that you can have. I'm going to show you a theorem for how to find all the rational ones. Okay, it's called the rational root theorem, okay, or in the future, you might just see me abbreviated as RRT. All right, so suppose that we have some polynomial, like 4x cubed plus 3x squared minus 8x plus 6. Okay, some kind of polynomial. Okay, and the key here is that the first coefficient and the constant cannot equal 0. This doesn't work if they equal 0. Those are the only two things you're going to have to look at to find the rational roots. You don't have to look at anything else. Okay? It's just the coefficient of the highest degree term and the constant. All right, so let's suppose that we're able to find a rational root. Okay, you could write it as a fraction. Okay, and I use the letters p over q. Okay, well, p has to do with a sub 0. This one, I'm going to focus on that. And what you do is you look at a sub 0 and you write down all the factors of it. So like if a sub 0 was 6, okay, the factors of 6 are positive and negative 1, positive negative 2, positive negative 3, and positive negative 6. Okay? Those are all the choices for the numerator, okay, if it was a 6. Okay, q has to do with all the factors of the leading coefficient. So let's say q was 5. Okay, the factors of 5 are positive negative 1, positive negative 5. Those would be your choices for the denominator. And we have to list every possibility we could have. Okay, all the different ones I said for p and all the different ones I said for q. All right, so we just need kind of a systematic way to list them. And I guarantee you, if there's a rational 0 in the function, this will find it. Okay, we'll do an example. Okay. Not every single possibility that you list is going to be a root. Okay, not every single option is going to be a root. What we're making is a list of possibilities. To confirm which ones are actually roots, well, we could graph it. Okay. We could use long division and divide it, see if we get remainder 0. Because anytime you get a remainder of 0, that proves it's a root. All right, so we still have to confirm what the roots are. Okay, but this is going to narrow down our options. All right. So I want to list the rational zeros for this function. All right, so first thing we're going to do is write all our possibilities for p and then for q. Okay, let's start with p. Okay, p is all the factors you can have of the constant. That's my constant. Okay, what are all the numbers that divide into 6 evenly? Yep, 3, 2, 1, 6. So we have 1, 2, 3, 6, and there's 4 more. All the negatives, yeah. Okay. So these are all the different options for our numerator. Okay. Now we need our denominator. What are the factors of 10?
1,
Yeah.
1, 2, 5.
1, 2, 5, and 10. Okay, so now what we're going to do is make a list of every possible combination we could have of P over Q. All right, so we just need kind of an organized way to go through it. Okay, let's start with the first one in P, and let's put that over every denominator in Q. So we could have 1 over 1. We could have 1 over 2. We could have 1 over 5. And we could have 1 over 10. Okay, and all those are positive or negative. Okay, the next one we could have is 2 over all the different denominators. So we could have 2 over 1. Now I could do 2 over 2, but do I already have that?
Yes.
Yeah, I already have 2 over 2. 2 over 5 I don't have. 2 over 10, do I have that one?
Yes.
1/5. So I already got that. You can write it if you want. Just once you reduce it, you'd see it's the same. Okay, now let's do 3 over everything. Okay, 3 over 1. 3 over 2, don't have that. Let's see, 3 over 5, I don't think we have that one. And 3 over 10, we don't have that one. Okay, and the last one, we'll do 6 over everything. So it's positive or negative 6 over 1. How about 6 over 2? We already have 3 over 1. Positive or negative 6 over 5. And 6 over 10 would be 3/5. We already have that one. Okay, so if there is a rational root to this problem, it has to be one of these numbers. Okay, has to be. So these are all the possibilities. How do we narrow down which one of these it is? We're going to graph it. Okay, and hopefully we have an idea what these are as decimals, like 3 over 2 is 1.5, 1 over 2 is 0.5. Just going to look at the graph. Okay. So let's graph it. 10x to the 5th minus 3x squared. So 10x to the 5th minus 3x squared plus x minus 6. Now these are all pretty small numbers. I think the biggest one we have is plus x minus 6. What's the biggest one we've got? Maybe 6? So we're not really going to have to look beyond positive or negative 6. Looks to me like it's going through 1. Okay, 1 looks pretty close. So the way I can check it is just go to my table, plug in 1 for x, see if I get 0 for y. No? Okay, I guess it's not 1. Let me zoom in a little bit. It's pretty close. Okay, but we have some fractions here that are just a little bit smaller than 1, too. All right, so yeah, I guess it's just a little bit less than 1.
I believe it's 0.95. That's what the book said when I was reading it earlier.
About 0.95?
Yeah.
All right, well, so this problem, all it really said to do was list the rational zeros. Well, we've done that. We made a list. I don't think any of these work. I don't think this problem actually has any rational zeros. Okay?
Awesome.
So we made the list, but I just don't think. Let's find what the 0 is.
That was a great use of it.
Yeah, that happens sometime. It's okay.
I believe the book said it's like
0.95. If I look at these fractions,
yes.
none of them are close to 0.95. I'm still going to ask you to make this list on a test, so you do have to know how to make it. And I promise, we'll do one later on that actually one of them works. So
would it be irrational? Would be irrational?
that's actually going to be my next example. We'll talk about that. Okay, so what we just did is we basically showed there are no rational roots. Okay, because if there were, it would have to be one of these. I don't see that one on the graph. All right, so now same problem. I want you to prove that this only has one real root. Well, we can look at the graph. It only crosses one time. But how can you prove to me that that 0.9505 is irrational? Kind of already said it. But why does 0.9505 have to be irrational?
Can't make it into a fraction.
Why not, though? Keep in mind what we just did. It's not one of these. Okay? If we were going to have a rational root, it has to be one of these fractions on the previous page. 0.9505 is not even close to any of these. Right? You got like 3/10, that's 0.3, 3/5 is 0.6, 1.5, 0.1, 2, 6, 0.2/5 is 0.4. There's nothing even close to that. All right. So since the root is 0.9505 and we have no fractions equal to that, okay, from example 1, 0.9505 must be irrational. Okay, it's not in the list of rationals. Any questions on that? Okay, it's not in the list of possible rationals. It's got to be something else. The only thing other than rational, irrational. Okay. All right, it's okay, and that's what you were saying, and that is correct. All right, so I'm going to show you guys a shortcut for doing division. Okay, this shortcut is only going to work if you divide by something of the form x minus a number, like x minus 2, x minus 8. So we can use what's called synthetic division. Okay, your book also gives another name to it. You might see in your book Horner's algorithm. Okay, we just call it synthetic division, but in the homework, if you see use Horner's algorithm to solve this problem, it just means synthetic division. All right, first thing you're going to do is write down whatever C is. Okay, it'll be the number after the minus sign. I'm going to put a little kind of backwards L. And then next to that, we're going to put all the coefficients of f of x. We're not going to have any letters here. This whole process is just going to be numbers. Right, so we'll fill in all the coefficients of f of x. Just like yesterday, if you're missing a power, fill in a 0 for any missing powers. Okay, the next thing is we're going to take the first coefficient and we're just going to bring it down. Okay, so I'll show you how this kind of looks on paper. What's nice too is this takes up a lot less space than long division. It's very compact. Okay, we're going to take the first coefficient and we're just going to bring it down. Okay, next we're going to take our divisor, okay, the number that's on the outside. We're going to multiply it by the coefficient we just brought down. And we're going to write the answer in the second column. So we're going to multiply two things together and write the answer in the second column. Okay, so after we write down the answer, we're going to have a number from the coefficient. We're going to have a calculation we just did. We're going to add those two things together. So we're going to add the number we just found to the coefficient that's above it and just write down our answer. And we repeat that process until we're done. Okay, and once we do a problem, I'll show you how you read your final answer. Okay, but it's basically, it's going to be the bottom row in synthetic division. It's going to be the coefficients of the quotient. Okay, so I'll show you how that works. Let's see if we can keep this up. Okay. So what I want to do here is I want to show that 3/2 is a root, okay, of 2x cubed minus 5x squared plus x plus 3. Okay, well, one way to show that it's a root is to divide 3/2 into it and see if I get a remainder of what? 0. Okay, so I'm going to divide 3/2 into it, see if I get a remainder of 0. And if I do, then it's a root. All right, so this is basically what you're doing. Taking this. And if I think 3/2 is a root, what would be a factor? X minus 3/2. So basically, I'm going to do this out right now. Except I'm not going to use long division. I'm going to use synthetic division. Step 1. Write down the number that comes after the minus sign. In this case, 3/2. Write down the coefficients of f of x. Somebody tell me, what are my coefficients in the numerator here?
2, -5,
Yep.
1,
1
3.
and 3. That's it. Okay, I'm just going to draw a line. And now step 1, or step 2, is bring down the first coefficient, 2. Now we're going to multiply the divisor times the number I just brought down and write the answer in the second column. Okay, what's 3 divided by 2 times 2? 3. Okay, add the number you just wrote and the second coefficient. What's -5 plus 3? -2. And repeat again. What's 3 divided by 2 times -2? -3. What's -3 plus 1? -2. They don't always come out to 2's and -2's. It's just the way this one's working. And remember, we're hoping to get a remainder of what? Hoping to get a 0. What's 3 divided by 2 times -2? And what's 3 take away 3? 0. All right? So this number is your remainder. The number farthest to the right is your remainder. Everything else is the coefficient of the terms before it. All right? So this would be your constant. This would be a number in front of x. This would be the number in front of x squared. The next number would be in front of x cubed, x to the 4th, and so on. Okay, so here's your quotient. 2x squared minus 2x minus 2. That's the quotient. So if you did the long division, that's what you'd get. Okay, so any question on how we showed that 3/2 is a root? We really showed x minus 3/2 as a factor. But that's equivalent to saying 3/2 is a root. Okay. Question? Now the last part says to write this in factored form. All right. So now we've got 2x cubed minus 5x squared plus x plus 3. Okay, that's equal to, well, what do we already know one factor is of this? We proved it. X minus 3/2. That's one factor. And what would be the other factor?
X squared minus 2x minus 2.
Yeah, 2x squared minus 2x minus 2. Like if I said to you, okay, factor the number 12, and I told you 3 is a factor. Take 12, divide by 3, look at your quotient. Quotient is 4. The quotient is the other factor. So in that case, 3 and 4. Well, x minus 3/2 is a factor. We proved that because we've got a remainder 0. So what's the other factor? Look at your quotient. This times this gives you what you started with. That's exactly what we just wrote. So any question on how we just factored that? Yeah?
Wait a second. So like how it's like 2, -5, 1, 3. The numbers beneath it. In order to find it, you just well plug it into that certain one. Like you show, for example, how you got that 3 below the -5.
3? So you take 3/2 times 2.
Yeah.
It gives me 3.
Okay, so just doing that order.
Yep. 3/2 times 2 is 3. Put it there and then add. Then 3/2 times -2, put the answer there and then add.
Okay.
Then 3/2 times -2, put the answer there and then add.
Yeah, the book just made it a little more confusing.
Yeah, it's synthetic division. We'll practice a couple more. Takes a little getting used to, but it's not that bad. Okay, let's use synthetic division to do this one. All right, we're dividing by x plus 3. Now, I said for synthetic division, you have to have it x minus a number. So this isn't exactly what we want. But it's close enough we could make it what we want. How can we do that? Aiden? Yeah, make it x minus -3. So Aiden, what number is going to be on the outside for synthetic division? Good, -3. And can anybody give me my coefficients? 3, 7, 0. 1 and -11. A lot of people forget the 0. Okay, you can't forget the 0 because there's no squared term here. Any question on that? All right, and then synthetic division can be really fast. All right, if you know exactly what you're doing, bring down the 3. -3 times 3. Add. 7 take away 9. -2. -3 times -2. 6. 0 plus 6 is 6. -3 times 6 is -18. Add. -17. Oh, we got a bigger number here. -17 times -3 is 51. And add. What's 51 take away 11? 40. Okay. Let me just double check, make sure. 3 -2, 6 -17. Yep, 40 is the remainder. Okay, so that's your remainder. What is my quotient? Can anybody interpret this last part to get my quotient?
3x to the cubed
Yep, 3x
minus 2x squared
minus 2x squared
plus 6x minus 17.
minus 17. Done. A lot faster than long division. But it only works if you're going to divide by something simple, x minus a number. If you've got division by like x squared, you got to go back to what we did yesterday. If you were smart, you might be able to figure out a way to extend synthetic division to work if you divided by like x squared plus or minus a number. You know, there might be a trick for figuring that out, but we'll probably just stick with long division. Okay, I want to show that 3 is not a 0. What is that equivalent to saying? If I want to show that 3 is not a 0, I could show that what is not a factor? X minus 3. So really, we're going to show x minus 3 is not a factor. And how do you show that something is not a factor?
Divide it in and see if the remainder is 0.
Yeah, divide it in, and we're hoping for a remainder that's not 0. Yeah. So if we don't get 0, that's not a factor. So 3 on the outside. Coefficients, I think this time they're all there. 2, 5, -2, -3. And John, can you kind of work me through what I'm going to do here?
Yeah, you're going to bring the 2 down?
Yep.
And then do 3 times 2?
Yep.
6. And then, so
Yeah,
So
yep.
11 and 33.
33.
And then add, so it's 31.
Yep.
And then 93.
93.
And then add, so it's 90.
90. What's my remainder?
90.
90. All right, so our remainder is 90. We just proved that x minus 3 is not a factor. It doesn't divide into it without a remainder, which means 3 is not a root. 3 is not a 0. Question on that one? All right. All right, so I think 3 more. Let's see what we have time for. Okay, let's see if we can find all rational zeros here. Okay, the first step to finding irrational zeros is list the possibilities. Then, once we have the possibilities, we can use the graphing calculator to narrow down which ones actually work. And then we can divide through synthetically to go from there. Right? Because if we can get this down to a quadratic equation, we can solve it very easily. Right? So all we need to do is find one root, divide through by it synthetically, and we can make this cubic into a quadratic. Okay, what are my options for P in this case?
1 and 2. Plus
Yep. And for Q?
1.
Yeah, just positive or negative 1. So there's not going to be very many possibilities here. It's going to be 4. You can have positive or negative 1. And what else? Positive or negative 2. So these are my possible rational roots or zeros. Okay, let's graph it and see if we can get an idea of which ones actually work. Okay, so we've got x cubed minus 3x minus 2. Okay, I don't have to zoom out very far because I'm only going to have to look from negative 2 to 2. I would say positive 2 looks like a root, maybe negative 1 also looks like a root. Just going to kind of check it on the calculator. Right. So when I plug in 2, I do get 0. Right? So I know 2 is going to be a root. Right? So let's off to the side just make an area for our roots. We have 2. And now if 2 is a root, what is a factor? X minus 2. So I'm going to use synthetic division. I'm going to divide through by this root to make this cubic into a quadratic. And I already know what the remainder should be when I do this. Okay, what should the remainder be? Should be 0. Okay, and then I'm going to look at the quotient. And the quotient is going to be a quadratic, and then I'll find the roots of that. Okay, but I got to get this cubic down to a quadratic by dividing through by a root. Right, so I get 1. 2 times 1 is 2. 2. 4. If I make a mistake, just let me know. 2. 0. Okay, so we already knew we're going to get a remainder of 0. But this is the part I'm interested in. Now we're going to find the roots of the quotient. So we get x squared plus 2x plus 1. And that's factorable. How does that factor?
X plus 1, x plus 2.
Yeah, I like the x plus 1. Another x plus 1. We have a repeated root, okay, which means, well, where is the repeated root? What number? Negative 1. Okay, remember what we said yesterday about a repeated root? The graph is going to go up. It's going to touch negative 1 and then go back away from it real quick. That's exactly what happens here. So just by looking at that, we should have maybe had an idea. Negative 1 was a repeated root. Now, instead of starting with 2, you could have started with negative 1, divided through synthetically by that, got the quotient, and then factored it, and then you would have gotten the other root. Okay, so as long as you can find one root to divide by, it takes your polynomial from a cubic down to quadratic. Okay, any question on that one? All right. Wait, let's try this one. Find the all rational zeros of 6x cubed minus 5x squared plus 3x minus 1. All right, my goal, what I hope is going to happen here, we're going to find one rational root, at least one. And we're going to divide through by it. Then we're going to make this cubic into a quadratic, which then we can factor and find the rest. Or maybe we have to use quadratic formula. But usually when you use quadratic formula, your answers are irrational. So hopefully it factors. If it doesn't factor, we probably don't have to worry about it. Okay, what are my possible options for P?
Plus or minus 1.
Plus or minus 1. Okay, how about Q?
Plus or minus 1. Plus or minus 2. Plus or minus 3.
Yep.
Plus or minus 6.
Okay, so let's list all the possibilities for P over Q. It's basically just going to be positive or negative 1 over everything. Okay, so possible, again, just the possible rational roots. Positive or negative 1. Derek, can you give me my next one?
Oh, yeah, you could have 1 over positive or negative 2.
Yep. 1 over, yep. What else?
You could have 1 over positive negative
Positive, negative a third, and
3. And positive negative 6.
positive or negative a sixth. Okay, let's graph and see if any of those look like possible roots. Or did anybody already graph it? See, yep. Does anyone look like a root?
Yep.
Which one?
Positive 1/2.
Positive 1/2? All right, we're going to trust Autumn positive a half. So what I'm going to do is divide through synthetically by a half. Hope that I get a remainder of 0, and then that proves it is a root. So put 1/2. And what are my coefficients going to be, John?
6, negative 5,
Oh, okay, yeah, go ahead, Jan. Sorry. 6, negative 5.
3,
Mm-hmm.
and then negative 1.
And negative 1. All right, so bring down my 6. Half of 6 is 3. Gives me negative 2. Half of negative 2 is negative 1. 3 minus 1 is 2. Half of 2 is 1. Perfect. Okay, so what Autumn said is exactly right. 1/2 is definitely a root. Now we're going to look at the quotient. See if we can get some more roots out of that. All right, so we got 6x squared minus 2x plus 2 equals 0. What could I do there to make that a little easier to factor on the left-hand side?
Take out a 2.
Yeah, why don't we take out a 2? So now we're just focusing on x squared minus x plus 1. Okay, is that going to factor?
What's another x squared?
Oh, thank you. All right, so that might change things. Is that... I don't think we can factor it. Okay, one thing we can check real quick. Let's just see if we were to use the quadratic formula, would we get imaginary answers? Okay, we could always check that. Okay, what's b squared?
1.
What's a?
9. Or 3.
3. And what's c?
1.
1. What's 1 minus 12? What does that mean if the discriminant comes out negative?
No real solution.
There's no real solution to this. Okay, there are solutions, but they're imaginary. All right, so you don't have to worry about trying to find solutions from that because the discriminant came out negative. So So it's not even worth bothering to try to even factor. All right, so this time, I'm hoping if I were to graph it, it should only cross the x-axis one time. Is that how it looked when people graphed it? Yep. It's not going to cross more than once. Okay. And let's finish up with this one. All right, so find all real zeros. Now this time, they want them whether they come out to fractions or you can't write it as a fraction. All right? Either way. Again, what has to happen here, we've got to be able to find a rational root. Divide through by it and get a quadratic. If we can't get a rational root here, we're stuck. There's nothing I've taught you today that would help. Okay, you have to find a rational root. So hopefully I picked numbers that make that happen. Okay, my possibilities for p, positive -1, positive -2. Connor, what are my possibilities for q?
3,
Positive -3, yeah.
-8. 8, or
So does 8 divide into 3?
8 divided 3.
You got to pick numbers that would divide into 3 without remainder.
Sorry, I have my blank. I got a little bit of sleep.
Anybody help them out? What are the other factors of 3? 1. All right, so positive -1, positive -3. That's q. And then p, positive -1, positive -2. Okay. Any questions on how you get those possibilities for p and q? Yeah.
Yeah, how do you get that?
So p is all the factors of the constant, any number that divides into 2.
Yeah.
Q is all the factors of the leading coefficient.
Yeah.
And then we have to write every possible option for p over q. So possible rational roots could have positive or -1, positive or -1/3. Okay, and if somebody can graph f of x and look at which one looks appropriate, that would help us out. We could have positive or -2 and positive or -2/3. All right, so now we need to graph it, look at the graph, and see which one of these 8 options looks like it might work. Okay, so after graphing that, anybody think they see one of these that would work? Kanan?
I'm not sure if this is correct, but it appears that I want to say 2/3 could work. I just need to take the equal to 0.
2/3? Anyone else think 2/3? Yeah? Okay, let's just try it. Let's take 2/3 and divide it in. So we got 3, -8, 1, 2. Bring down my 3. 2/3 times 3 is 2. -8 plus 2 is -6. Okay, I'm going to do 2 times -6 is -12. Divide by 3 is what? -4. 1 take away 4 is -3. 2 times -3 gives me -6. What's -6 divided by 3? -2 plus 2, 0. So perfect. Yep. Good job. 2/3 is a root. Okay, now let's focus on this quotient. 3x squared minus 6x minus 3. Yep, factor out of 3. That's minus 2x minus 1. Okay, and does that factor? No, because you're going to need a -1 plus 1 to get that, and that would wipe out your middle. So what we're going to do plug it into quadratic formula real quick. If it comes out imaginary, we're done. If it doesn't, we're going to write down the two answers we get because it said all fractions and non-fractions for roots. All right, so we get negative b plus or minus the square root of b squared minus 4ac all over 2a. What happens with minus minus here? Yep, becomes a plus. So now we're good. We're not going to get imaginaries. So we're going to get 2 plus or minus the square root of 8 over 2. How can we write the square root of 8? 2 times the square root of 2. And we can cancel the 2 everywhere except under the root. 1 plus or minus square root 2. Yep. 1 plus or minus square root 2. So this one should cross the x-axis 3 times. And anybody who graphed it, did it cross 3 times? Yep. It'll cross here. 1 plus the square root of 2 and 1 minus the square root of 2. All right, so that's how you find roots, okay, using synthetic division. Yep, so for homework, okay, it's on page 183. And it's 1, 2, 5, 6, 9, 10, 13, 14, 17, 18, and 27. Okay, there are some other things you can use synthetic division for. They're in the section, but we're not going to look at them this week.